Alright, so for this test you need to remember the product rule and the power rule. So let me quickly jot that down, and I want you to jot it down in your notes or your study guide as well. Remember the product rule, and this should be in your notes, states if you're multiplying two monomials like x to the 5th times x to the 3rd, you add the exponents. It'll be x to the 5 plus 3, which is x to the 8th. Okay, whereas the power rule states that if you are raising an exponent like x to the 5th power to another, if you're raising a monomial to a power, you multiply the exponents. So 5 times 3 is 15. But keep in mind that this doesn't apply to the coefficients. So for example, if you were using the product rule and you're multiplying 2x to the 5th times 4x to the 3rd, you would still multiply 2 times 4 like you would normally. So that would be 8x to the 8th. Or if this was 2x to the 5th raised to the 3rd power, you would still raise 2 to the 3rd power like you normally would, which would make this 8x to the 5th. Now, let's get started. So write each polynomial in standard form. So to do that, we need to discuss and identify the degree of each monomial. So this monomial has a degree of 2. This monomial has a degree of 4. This monomial has a degree of 1. This monomial has a degree of 3. And this is the constant. So if we were writing this in standard form, we would write 3a to the 4th first. And that would be plus 2a to the 3rd. Then plus a squared. And then minus 7a, and then minus 4 at the end. That would be standard form. If we look at this one, this monomial here has a degree of 3. This monomial, remember you have to add up all of the exponents, so this would be 1 plus 2, so this would also have a degree of 3. But because it has an x there, we'd probably put that before the 8y to the 3rd. If we look at this one also has a degree of 3, and this one also has a degree of 3. So I'm going to start with 2x to the 3rd, which has a degree of 3, minus xy squared, minus x squared y, and then plus 8y to the 3rd. Now, if you had one like this, I wouldn't really take any points off. As long as you remember that this one should be last, then you'd be okay, because all of them have a degree of 3. Classify each polynomial by degree and the number of terms. So if we look at this, remember when we're classifying a polynomial by the degree, we only look for and it's already in standard form, we only look at the first monomial here to figure out the degree. And all of these are already in standard form, so this would be first degree, and then 2 terms is a binomial. Remember, 1 term monomial, 2 terms binomial, 3 terms trinomial, 4 or more terms, we just say polynomial. All right, this would just be a constant, and only 1 term, so it'd be a monomial. If we look at this one right here, this would be a second degree, and it has 3 terms, so it would be a trinomial. And if we look at this one right here, this would be a 4th degree. And it has 4 terms, so it would be a polynomial. Actually, 5 terms, so it would be a polynomial. Simplify each polynomial, write all answers in standard form. So number 7 is just a subtraction problem. We're subtracting 2 polynomials. So remember when you're subtracting, excuse me, when you're subtracting, you need to change all of those signs in the second polynomial to their opposite. So this would change to 2x squared plus 3x plus 2 because the first polynomial will remain the same. Then that positive x squared would be a negative x squared. That negative 4x would be a positive 4x. And that negative 1 would be a positive 1. Another way of thinking about this is you're distributing the negative. Okay? And then you just simply combine like terms. Alright, so we have 2x squared here and negative x squared. 2x squared minus x squared is going to be x squared. Then we have 3x here and 4x. 3x plus 4x is going to be 7x. Then we have 2 and 1. 2 plus 1 is 3. It's in standard form, and this would be a second degree trinomial. here, before we add, we would need to distribute the 2a to the third power to each of those terms on the inside of that binomial. All right, so here you would need to use the product rule. So when we're using the product rule, remember we add the exponents. We'd still do the coefficients the same way. 2 times 5 is 10. But a to the third times a to the second would be a to the 3 plus 2, or a to the fifth. We add the exponents. Now, 2 times negative 7, negative 14. But a to the third times a would be 3 plus 1, which would be a to the fourth. And we're adding that with 3a to the fourth minus a to the fifth. So now we would just simply combine like terms. We have 10a to the fifth and negative a to the fifth, which would make this a 9a to the fifth. And then we have negative 14a and positive 13a, which would make this a negative 11a to the fourth. This would be in standard form, and this would be a fifth degree binomial. Next, again, we're going to need to distribute to all three terms. Okay, so this would be 5 times 9, and I was really hoping to, did I not put a problem like that on here? Oh, yes, I did. All right, so let's keep doing this one. This would be 5 times 9, which is 45. Then c squared times c squared is c to the fourth. Again, remember product rule, 2 plus 2. And d times d squared would be d to the third. Okay. Then we distribute it to the next monomial. So 5 times negative 4 would be negative 20. C to the third times c squared is c to the fifth. And d times d is d squared. And then the last one, 5 times negative 2 is negative 10. C squared d. All right, no terms that you combine. So this would be a seventh term trinomial. Excuse me. Number 10, I don't believe this was supposed to be here. Number 10 is this right over here. All right, so here is an example of the power rule. Right here, we are raising this monomial to the second power. So that means we would need to use the power rule, which means we'll multiply the exponents. Now, there is a coefficient here. The coefficient is negative 1. Negative 1 squared is negative 1 times negative 1, which would be positive 1. Okay, so that'll turn that into a positive. That'll get rid of the negative. A to the 6th squared, if we use the power rule, that's 6 times 2. 6 times 2 is 12. That would be a to the 12th power. And then b raised to the second power would be b squared. All right, then that's plus 9a to the 12th power, b to the second power. Now, can we add these? Absolutely, because they have the same variables raised to the same power, so we can add them. And that would just be 1 plus 9, which is 10. A to the 12th, b to the second. This would be a 14th term monomial. And it's only one monomial, so obviously it's in standard form. All right, next, let's take a look at this one. Excuse me. So I'm going to first want to use the power rule here. Now remember, power rule doesn't apply with the coefficient, so it's only the exponent that's attached to the variable. So 5, we'd actually have to square. 5 squared is 25. Now, v to the fourth squared, that would be where we use our power rule, and that's 4 times 2. 4 times 2 is 8, so it would be v to the 8th power. And that's times 2v to the third power times v. Now we just have multiplication. So now we would use the product rule. So we would add all the exponents. 8 plus 3 is 11, so that would be 25 v to the 11th times v. Then we have 11 plus, remember there's a 1 here, 1. So that would be 25 v to the 12th power. That would be your final answer. This would be a 12th degree monomial. All right, 5y minus 1 squared. That's 5y minus 1 times 5y. There's a line in the middle there. Let me take that off. I don't like that line in here. Sorry. There we go. Times 5y minus 1. Multiplying two binomials, so we'll FOIL it out. First terms, 5y times 5y, that's 25y squared. O stands for outer terms, so 5y times negative 1 is negative 5y. I stands for inners, so it would be negative 1 times 5y, which is minus 5y. And then L stands for last, so it would be negative 1 times negative 1, which is positive 1. And then we combine like terms. So we have negative 5y and negative 5y, which would make negative 10y. So this would be 25y squared minus 10y plus 1. This will be your final answer. And this would be a second degree trinomial. Number 13. Two more binomials that we're multiplying, so we must use FOIL first. Well, you don't have to use FOIL, but that's an easy way of doing these. So first would be 2x squared. Okay, then outers, which would be a minus 6xy. Then inners, which would be plus 5xy. Then last, which would be minus 15y squared. We have two like terms here that we would combine, so this would be 2x squared minus xy minus 15y squared. And you don't need to do this, but just for practice, this would be a second degree trinomial. All right, so here we're going to multiply. I'm sorry, we have the power rule. I didn't see that there. We would need to use the power rule there, and then we would multiply these two monomials. So if we use the power rule, remember we have to actually raise 2 to the third power, and 2 to the third power is 8. A squared to the third power, if we use the power rule, that'd be 2 times 3, which is a to the 6th power. And then that would be plus, now here, this is just a product, this is multiplication, so we'd use the product rule. That would be 3, and then a squared times a to the 4th would be 4 plus 2, which is a to the 6th. Can we add these two? Absolutely. Same variable, same exponent. So we would just add the coefficients. This would be 11a to the 6th power. Final answer, 6th degree monomial. All right. This one has a bit of everything. So we have the power rule, we have the product rule, we have subtraction, everything on there. Let's first do the product rule. So right over here, this would be product rule. So we would need to raise 3 to the 4th power first, which would be 81. X to the 3rd to the 4th power, that would be 3 times 4, which is x to the 12th power. And then y to the 4th would be y to the 4th power. Now, over here we also have the product rule. So we would need to raise 7 to the 2nd power, which is 49. X to the 5th raised to the 2nd power, that would be the power rule, so that's 5 times 2, which is 10. And then y to the 1st raised to the 2nd power will be 1 times 2, which is 2. And that's times x squared, y squared. Before we could actually subtract these two, we would first need to multiply. Okay, now that's negative 49 times 1, which would still be negative 49. And I'm going to bring this part down. And then x to the 10th times x squared, that's the product rule, so it would be 10 plus 2, which is 12. And y squared times y squared, that's again the product rule, which would be 2 plus 2, which is 4. Excuse me. Can we combine these two? Absolutely. They have the same variable raised to the same exponent. So this would be 81 minus 49, which is 32. And that would be x to the 12th, y to the 4th power. And the last problem. This is a binomial multiplied by with a trinomial, so we'll just have to multiply this first monomial by every single monomial in that second trinomial. So first it would be 3a times 5a squared, which would be 15a to the 3rd. Then it would be 3a times 2a, which would be plus 6a squared. And last, it would be 3a times negative 6, which would be negative 18a. Now, we need to do the same thing with the 1. So if we do that, it would be plus 5a squared. And then 1 times 2a is plus 2a. And then 1 times negative 6 is minus 6. Last step is to combine like terms. So we have this 6a squared and this 5a squared. Bring 15a to the third power down. 6a squared plus 5a squared is 11a squared. Then we have this negative 18a and this positive 2a. Negative 18a plus 2a is negative 16a. And then we have that minus 6. We have combined all the terms that are alike. This would be a third degree polynomial. And that is it. That's your study guide. Be prepared for that test tomorrow. Make sure you know what the product rule is, power rule is. Make sure you know how to change polynomials to standard form. And make sure you know how to name and classify polynomials. That will all be on your test tomorrow. I will hope you have a great day, and I will see you tomorrow.